here we have lesson 91. In this lesson, we will continue to look at probability questions and recall one very important operations, the choose notation, that you have learned in chapter 1 in your textbook last year. And we learned the and choose R notation is usually used for counting the number of ways to pick a combination when order doesn't matter. So if you have n object and you want to pick a certain number out of the n, say like 3 objects out of 10 objects, and you want to figure out how many different ways, different combinations you can come up with when order doesn't matter, you'll be using the and choose R notation. In the Maclaurin series lessons recently, you have also saw this as the binomial coefficient, right? So here we're restricting ourselves to the counting, so n and r in this case would be discrete numbers. And then the formula for doing and choose r is n factorial over n minus r factorial times r factorial. Alternatively, if you're interested in finding how many ways to arrange, say the 3 objects out of the 10, so when you have like ABC that is different from BCA, then you'll be using permutation, which is the NPR notation. Okay, so don't mix them up. If you're still confused, go back to your year 1 notes, and there were some examples of that in those lessons. Okay. So in lesson 91, let's begin by looking at the first example. There are 8 interns and 5 supervisors working in a lab. 4 people are selected to form a working group. Part A, find the number of possible working groups formed. Because we want to have 4 people in each working group. And we have a total of 8 plus 5, 13 people. In the group, I don't really care if A, person B, person C is in there, or person C, person B, person A is in there, because it really makes up the same group. So order doesn't matter. So in this case, we know for sure we're using the choose, the combination notation. 13 choose 4. Using your calculator, it gives you 715. Okay? Part B, find the probability that there is at least one supervisor in the working group. So this time is slightly different. In order to make sure we do have a supervisor, right, we have to separate the intern group from the supervisor group. Another part of this question also mentioned that, well, there must be at least one supervisor, meaning I can have different cases, right? If I have one supervisor, I must have 3 interns. 2 supervisors, 2 interns, 3 supervisors, 1 interns, and if I have all 4 supervisors, it still fits into this criteria. But if we are listing the 4 cases, which case have we actually missed out on? We're missing the case where we have no supervisors but all 4 interns. So it looks like from a calculation perspective, it's more efficient to do the complementary events in this case. So let me write this down. The probability of at least one super is equivalent to taking away the probability of having no supervisor from the entire sample space. Okay? So now, how do I calculate the number of working groups that I can form with no supervisors? Well, of course, from the supergroup, I choose nobody. And from the 8 interns, I choose 4 of them. And it's a multiplication, right? Because this is the end of 2 events. And then 13, choose 4. Okay? So this works out to 1 minus 70 over 715, or 129 over 143. Okay? Example 2. 5 songs are chosen at random from the following playlist. We have songs by BTS. How many are there? Let's see. 1, 2, 3, 4, 5. So 5. 2 Taylor Swift, 1 Shawn Mendes, 1 Adele, and 3 Ed Sheeran. Okay, so question is, 8. What is the probability of choosing all 5 BTS songs? Okay, so here we're not really arranging these songs into another playlist. So I'm just going to assume that we're just picking combos of songs because order does not matter. So that means P of 5 BTS is, I have 5. I'm choosing all 5 out of, how many songs are there in total? 5, 10, 12. We're comparing that to picking from 12 songs, choose 5. Using my calculator, it works out to 1/792. Part B. What is the probability of picking more songs by BTS than Ed Sheeran? Okay, so let's do a chart here. I think it's easier to compare. So, all right. So BTS, we want a total of 5 songs. So obviously, if I pick 5 BTS, I get none of Ed Sheeran's. 4 and 1, 3 and 2. Now, if I keep picking, I'm gonna have 2 and 3, which violates what we're looking for because we need more BTS songs. So that means there are 3 cases in total. In order to compute this probability, so more BTS than Ed Sheeran. That means I need to add the cases of 5 choose 5 over 12 choose 5 plus 5 choose 4. 5 BTS choose 4 times 3 Ed Sheeran choose 1 plus 5 choose 3 times 3 choose 2. Okay? Out of 12 choose 5. If I work out case by case, I get 1/792 plus 15/792 plus 30/792. Simplifying, this gives me 23 out of 396. Okay. Here is question number 3. Find the probability of being dealt a 5-card poker hand with exactly 2 aces and 2 kings. Okay. So remember that we are going to assume that we are using a standard deck of 52 cards with no jokers. So to get exactly 2 aces and 2 kings, we restrict ourselves to the selection of aces because there are 4 aces. You choose 2 of them. Multiply by 4 kings, choose 2 of them. But we still need 1 more card to make up the 5-card poker hand. So how many cards remain that are not aces nor kings? It'll be 52 minus 4 minus 4. Choose the last card. But if there is no restrictions, how many 5-card poker hands can I come up with in total? Well, I just randomly pick 5 cards out of the 52. Okay. So for you to check your answers, I'm going to work out the individual parts. 4 choose 2 is 6. 4 choose 2 is 6 again. Here I have 52 minus 4, 40. So 44 choose 1, which is 44. And 52 choose 5 is 2,598,960. So this is actually how many different poker hands you can actually come up with. Okay? And this simplifies to either exactly 33 out of 54145, palindrome, or roughly 0.0609%. Really, really low, right? Okay, number 4. Let's form some passcodes. So number A, how many 5-letter passcodes can be formed using any letters from A to Z? And you may repeat letters. So last year when we do some questions like this, I said that, well, if you prefer a more visual way to picture this question, use blanks, right? Because 5 blanks for 5 letters. And then you consider, well, what can I use in each blank? How many choices can I put into each blank in order to form the passcodes? Now, because we are allowed to repeat letters, and in this case, if I have 1, 2, 3, 4, 5, it's a different passcode than 4, 5, 3, 2, 1. Okay? So that means order does matter. So in a sense, if we are doing this, we need to consider arrangements, number of arrangements. Okay? So think, how many choices do I have to make up the first letter or first digit in the passcode? 26, right? Because there are 26 letters in the alphabet. And then how about the second blank? Another 26. Third blank, another 26. So for all of them, I can have 26 choices multiplied by 26 times 26, all of them 5 times. So I can have 11,881,376 different passcodes from A to Z. Okay? B. Calculate the probability of getting a 5-letter passcode which contains 3 different consonants and 2 different vowels. This is different now, right? So what's the criteria? We have to choose 3 consonants. And how many consonants are there? Or maybe let me ask the second question first. We have to choose 2 vowels. How many vowels are there? A, E, I, O, U. So 5 vowels, so 21 consonants. Once we have these pre-selected 5 letters, we still have to put them into spots, right? The 5 different spots. So the next step is to then arrange into passcodes. So you see how this adds some complexity to the question that we were talking about. So in our calculations, let's do some counting. So probability of getting 3 consonants and 2 vowels, and they are different, okay? Is first pick 3 from 21. So 21 choose 3. Order doesn't matter yet. Then pick 2 vowels from 5. Order doesn't matter yet. But now how many letters do we have in our hand? 5. Then we're not repeating them, right? So there's 5 ways to pick the first spot, 4 remaining letters in the second spot, and so on. So that means this is really 5P5. I should use the IB notation. But 5P5 is also equivalent to 5 factorial out of what if nothing matters, right? Then it is the 26 to the power of 5 matter. Okay? So let's work this out. 21 choose 3. My calculator gives me 1330. 5 choose 2. My calculator gives me 10, or you may recognize that this is, from the Pascal's triangle, 1 5 5, 1 5, 10 10, 5 1, that row. Okay, so it's 10, and then 5 choose 5 is 5 factorial, which is 120. And then we already got this number. I'm going to keep it because it's too messy to write it out. And this works out to roughly 0.134 if I rounded to three significant figures, or roughly 13.4%.